Hey everybody, this is Mr. Munson, and we're finishing up Unit 5. This video comes at number 4, and so it's called 5.4 Classifying Triangles Using Pythagorean Theorem Converse. This video is dedicated to Kiana and my 6th period class that loves deep-fried mozzarella sticks like nothing else. To be honest, I love them too. I told her she didn't have to come back to class ever again, and she would just get an A for having good taste. Those look good right there. Okay, feel free to put me on pause and stare at those sticks. Hit play when you're ready, and then we can begin.
Okay, so let's get started. We're looking at 5.4, classifying triangles using the Pythagorean theorem converse. So two things before we begin. First, Pythagorean theorem. You should have that one already. And so you should know that, the Pythagorean theorem is a squared plus b squared equals c squared. And the hypotenuse of your triangle always goes in that c squared. It's also known as the largest side, okay? The largest side always goes there. All right, the second thing is converse of any statement, okay? So let me just start with telling you, I'm just going to kind of briefly talk about this. We're going to actually go into a logic unit where we talk about converse and inverse and contrapositive, all these very technical logical terms and stuff, so we're going to get into it. This one's really easy to understand, and quite honestly, many of you already know what it means. So suppose I had a statement like, if it's raining, then the ground is wet, okay? That's a statement, and so its converse is when you take and you move it's raining, the first part of this statement, and you put it in the second part. Then you take the first part, or the second part, and you put it in the first part. It's just switching the main ingredients. So now you have this statement, if the ground is wet, then it's raining. All right, so pretty simple stuff there, okay? All right, let's move on. Okay, so when we're classifying triangles, we always classify them in two kind of categories. We're looking at the side information. We can label it equilateral, isosceles, or scalene, or by the angle information, it's equiangular, acute, right, or obtuse. If you're not sure what those words mean, I need you to refer back to a previous unit and the vocabulary words. So go ahead and put me on pause and take a look at these problems that are over here to the right, and put me on pause and classify them. Choose from the sides and the angle list. So each one of them will have two names. Okay, welcome back. Looking at the first two, I had to find some angles first, and so I found in the first one it's a 90. So looking at the angles, I can classify as a right triangle. Looking at the sides, it's isosceles. The reason I can mark those two green marks on there as being congruent is from the isosceles triangle theorem. It says that if the angles are congruent, then the sides opposite them are congruent, right? So I taught you about drawing your arrows. Okay. All right, looking at the next one, it's obtuse. I had to find that 125 using the triangle sum theorem. They all have to add up to 180, right? So obtuse, because that one's 125. It's scalene. Even though I don't know anything about the sides, I know that since all the angles are different, then the sides are all different. Okay. Now take a look at this next one. So I know that by my isosceles triangle theorem that these two sides are congruent, therefore the angles are congruent. So I can put a 60 right here. Okay. Now I have, that I could have found it by the triangle sum theorem or whatever, but basically it comes back to this is not just an isosceles triangle. Since all the angles are congruent, I can also mark that side congruent to the others, right? Across from all the same angles or the same sides. So it's an equilateral triangle or equiangular and an equilateral. Okay, so that's classifying the triangles by their sides and their angles. Now notice how if I know the information about the angles, I can find out everything about the sides in the sense of these names. That's not true in the next kind of problem. Now looking at this problem, I can clearly see this is a scalene triangle. All the sides are different. but I don't know anything about the angles. I just know that they're all different angles, but I don't know if any of them are right. I don't know if they're all acute. I don't know if any of them are obtuse. Again, I'm not going by my eyes. It looks like an acute triangle, but it could be something else, just a bad drawer, let's say. So let's actually look at something that will help teach us how we can now, given the sides, be able to determine what kind of angles are inside. The tool here that we're going to use is called the Pythagorean Theorem Convert. So here's what the Pythagorean Theorem Converse says. If I have three sides of a triangle, they're just in a list, let's say, or in this case, 3, 4, 5, and I plug them into the Pythagorean Theorem, and the left side equals the right side, if a squared plus b squared does equal c squared, then the triangle is a right triangle. Okay? All right, so one of the things to keep in mind is we're not sure if the left side will equal the right side, so I always like to put a question mark above it, but always remember that what's in the C spot, whatever number you're sticking in for the C, has to be the largest side of the ones given. Now suppose I'm given three sides of a triangle and they're all the same. I know for a fact it can't be a right triangle. It has to be a right triangle or an obtuse triangle. It actually has to be equiangular. Since these three sides are the same, the angles are the same. So we already know this is equiangular, and I'm not going to even use this kind of problem on the Pythagorean theorem, or I'm not going to use the Pythagorean theorem converse on this kind of problem. That's an easy one. Okay, so now let's look at this one. Okay, I don't even need to draw a triangle. All I need to do is take those numbers and stick them into the Pythagorean theorem, being careful to always stick the largest side in on the C side. Okay, so now let's go through these numbers, and I get 9 plus 16 equals 25. I'm keeping my question mark here to remind myself they might not equal. Okay, so when I get down here, I get 25 equals 25, and indeed that is a right triangle. Okay, so if I was to classify this, I would classify it as an isosceles right triangle. I'm sorry, a scalene right triangle. Scalene right triangle. Okay? The reason is because all the sides are different, and Pythagorean theorem converse fishes out that the two smaller sides squared and added together equals the C side. Now let's take a look at a set of three that does not work. Okay? All right, so we got, 9 plus 16 equals 36, and this ends up being 25. And of course, I've left my question mark off. Okay, so it's not equal, so I'll just cancel that out. And I'm going to write 25, 36, and I'm going to put an inequality sign in there. Since the 36 is big, I'm going to put it just like that. Okay, so now I know it's not a right triangle. Now, if you look back at our list, our only choices at this point is that it's either obtuse or acute. Okay, let's write some rules. Okay, I call this the three bears theorem. Hopefully you pick up on the reason why. So we have a couple of different choices. The a squared plus b squared is less than c squared, or a squared plus b squared is greater than c squared, or a squared plus b squared equals c squared. Okay, so when a squared plus b squared ends up being where c is too big, right? It's too big, then it's obtuse. Okay, when a squared plus b squared it creates such a way that the c squared is actually too small, then it's acute. And then when the c squared is equal to the a squared plus b squared, it's just right. Hence the name, the three bears theorem. And you're welcome. All right, it's time for you to try it, right? This is where you're going to try to apply this rule to these numbers, okay? So just put me on pause and see if you can do this problem on your own. Come back in a few minutes and check your work. Go ahead and put me on pause. Okay, from the category of angles, we call this an acute triangle, okay, because it falls to being where the c squared is too small to go with the a squared plus b squared, so it's acute. And then we look up and we see all three sides are different, so it's an isosceles triangle. Okay, we always have two names for it. Let's try one more. All right, try that one. Go ahead and put me on pause. All right, this is obtuse and scalene. Now let's just go back to the previous problem. I apologize. I made an error. This should have been scalene. Sorry about that. Scalene. Okay. All right, so go ahead and draw your line. Write a real quick summary. This one should be pretty good, pretty easy. Okay, let's move on to our do it problems. All right, there's your do it problems. Be real careful now. I need you to show your work on 1, 2, 3 as all the time. All these problems, show your work. Write up the equations. The 1, 2, and 3 problems you should be exactly like I'm doing in the video where I'm writing out the equation, question mark, and you're just modeling it exactly the way I did it. Don't want to do it that way? No worries. I can't give you all the credit. Number 4 is a problem that you've been doing since probably 7th grade, right? Find the missing side of a right triangle. Okay? And then finally a bonus, why is the triangle 1, 2, 3 not an obtuse triangle? All right. Take care, you guys.